Okay, so here's one other really neat property about Conway's sequence that's different than the Collatz conjecture. Just like in the Collatz conjecture, if I have any number here, like 4, we can see where it goes.
Yeah.
In this case, it's even, so it's 2 times 2, so we send it to 3 times 2, which is 6. But an interesting thing is, what's different about this than the Collatz conjecture is...
I don't think it ever goes to 1.
Well, this one doesn't go to 1. We saw that last time, and in fact, they think that almost no numbers go to 1 in this. In fact, they think it for most numbers that you put in, and we'll see this on the computer in the next video, they think most numbers actually go to infinity, which is interesting.
They keep getting bigger?
Yeah, but that's not what's interesting I was going to point out here. What I was going to point out here is on this side also. Remember how we talked about you got all the numbers on this side?
Yeah.
Because you had the even numbers, one more than a multiple of 4, one less than a multiple of 4. What do we have on this side?
Well, you've got one more than a multiple of 3 and one less than a multiple of 3. And a multiple of 3.
Okay, so what does that mean on this side?
So, well, if you have some numbers, you have all the multiples of 3 and the even numbers on both sides of them.
I don't know what you mean.
Well, like if we have like if we say 0, 1, 2, 3.
Okay.
0, 1, 2, 3, 4. So we have all the multiples of 3.
0.
3 and 6. And we have
Then,
one less than a multiple of 3 and one more than a multiple of 3.
so on this side, we can hit.
That's one less.
And this
And
is
one
one
more.
more.
That's one more. You said they were always going to be even on either side of a
Well,
multiple of 3.
It looks like they aren't. It
Okay.
looks like the ones that are less. Well, actually, it looks like it's going to vary.
Okay. Are all multiples of 3 odd?
No,
Why not?
because you can have 3 times an even number.
Okay. There you go. You got the right idea. I have 3 choices over here. Multiples of 3, one more, one less. That hits all the numbers. And it hits all the numbers in exactly once. And that means if I'm at 6,
There's only one choice for it to go.
well, there's only one choice for it to go, but there's only one choice of where it came from, too,
Yeah.
which is interesting. This can never be 6,
Because you have a multiple of 3 and you added 1.
and this is a multiple of 3. This can never be 6.
Because you subtracted 1.
So it has to have come from 3x. So on this one you can go backwards, which is interesting. You can run this backwards and forwards. The Collatz conjecture doesn't have that property because you're going to 3x plus 1 and 2x.
Yeah.
Okay? If it's odd, if it's even.
Yeah.
Sorry, x over 2. But the problem is sometimes these can be the same. So 7, for example, if you were at 7, maybe you came there from 14 divided by 2.
Yeah.
But maybe you came there from,
Two.
sorry, I picked a bad number. 10. Maybe you got to 10 from 20 divided by 2.
But maybe you got from it
3 times 3.
3
Plus 1.
goes to 10. So the problem is you can't run the Collatz conjecture backwards because you have numbers like 10 that you don't know, you could have come from 2 different places. So if you ran it backwards, you get these branching trees.
Yeah.
And that doesn't make any sense. But on Conway's one, it's unique going backwards and it's unique going forwards,
Yeah.
which is pretty cool.
Yeah.
And that sort of lets people think also about why it doesn't always end at 1 and why it might be infinite. But Conway calls this an amusical. He makes up this word amusical for this, and it's because you might know the answer to this because you're taking piano. Do you know how many notes there are in an octave?
There's 8.
Are you sure?
8 notes in an octave.
How many keys are there in an octave on your piano?
Well, there's 8 notes to the next. If you had a C, there's 8 notes to the next C.
How many black keys are there too? Are those notes?
Well, yeah.
Okay.
I thought you meant just the white keys.
No.
There's the 8 white notes plus there's 2 black keys. There's C sharp and there's the 2 black keys and then three other black keys.
Okay.
So there's 13.
Okay. But when you go 8 notes in an octave, A, B, C, D, E, F, G, A,
Yeah.
you get back
To A. To get back to A.
So there's really just 7 there, right? Plus the 5?
Yeah.
So how many is that?
It's 12.
12. Okay, so somehow this relates to an octave, and he explains it in his paper. But we're going to do it on our computer, okay?
Yeah.